Alright, you guys, please turn to 4.2, apply congruence in triangles. Congruent figures. In two congruent figures, all the parts of one figure are congruent to the corresponding parts of the other figure. When I say all parts, that means all the sides, all the angles, all the parts. Now, corresponding parts. In congruent polygons, the corresponding parts, once again, are the corresponding sides and corresponding angles. So, for example, in these two triangles, this side would correspond to this side would correspond to this side, and this side to this side, because those are the congruent sides. And I could do the same thing with the angles. This one with this one with, it would be this one, and this one with this one. Okay? Alright. So, for example, write a congruence statement for the triangles. Identify all parts of congruent corresponding parts. Okay, when you are writing congruence statements, it's very important that you correctly order the letters. So, for example, in this case, we have triangle ABC. Notice that A comes first, B comes second, C comes third. A is the right angle. It corresponds with the other right angle in the triangle. Yep. This one. So because A comes first and it's a right angle, in the other triangle, F has to come first because that's also the right angle. Likewise, angle B, that's the second one, corresponds with G. Notice how both of those have only one arc. And then the last one would be H. Okay? Corresponding angles, angle A is congruent to angle F. Angle B is congruent to angle G. Angle C is congruent to angle H. So, notice that A and F are first because they're congruent. B and G are second because they're congruent. C and H are third because they're congruent. Now, if you were to order these letters differently, like BCA, then this would be triangle, let's see here, BCA, GHF. Okay? It doesn't really matter the order as long as they line up with each other. Alright? Okay, corresponding sides, AB, it has two dashes, so it corresponds with FG. BC has three dashes, so it corresponds with GH. And CA corresponds with HF. Okay, use properties of congruent figures. In the diagram, QRST is congruent to WXYZ. Now remember, because they're telling us they're congruent, all the corresponding angles are congruent, all the corresponding sides are congruent. That means that angle Q is congruent to angle W. Angle R is congruent to angle X, etc. Line or segment QR is congruent to segment WX. The order of the letters matters. Find the value of X. So let's see here. We have an X here. W, it's the first one, corresponds with Q. So these two angles we know are congruent. Alright. Angle Q, congruent to angle W, so the measure of angle Q equals the measure of angle W. Angle Q is 65 degrees, angle W is 5x plus 5. If I subtract 5 from both sides, I'm going to get 60 equals 5x. Then I can divide by 5 and I get x equals 12. Okay? Alright, let's solve for y. We know here that x is 12. Okay? QR, that's this side here, corresponds with WX. So QR equals WX because QR are the first two letters and WX, that's the first two letters of the second one. QR has a length of 6. WX has y minus x. Now we know that x is 12. So I'm going to substitute 12 for x. Now, if I add 12 to both sides, I get y equals 18. Alright, let's go on to page 2. Checkpoint. You guys can do those. And let's see. Maps. If you cut the map in half along PR, let me draw what's missing here. This is a right angle, and this is labeled Q. This continues here. This is angle 3. This is angle 4. And this is R. And there are 2 dashes here. It's a rectangle. Okay, if you cut the blah, 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 will the sections of the map be the same size and shape? Alright, from the diagram, angle S is congruent to angle Q. Because all right angles are congruent. Also, by the lines perpendicular to a transversal theorem, PQ is parallel to SR. Okay, because 2 lines perpendicular to the same line have to be parallel to each other. So, if these lines are parallel, then angle 1 has to be congruent to angle 4. And angle 2 has to be congruent to angle 3. Because those are alternate interior angles. Okay, so all pairs of corresponding angles are congruent. These angles are congruent, these angles are congruent, these angles are congruent. So all 3 angles in each of these triangles are congruent. Now, it shows that PQ is congruent to SR, or RS. Doesn't matter which order you write the letters in. QR, it's shown, is congruent to SP. So, also, PR is obviously congruent to itself. That's reflexive property. By the way, this says by, if you can't read it. All corresponding parts are congruent. So, we've shown all the angles are congruent, and now we've shown all the sides are congruent. So, triangle PQR is congruent to triangle RSP. Remember, you make sure you order the letters correctly. So, P, that's this one, has to be the same place as R, because those are the corresponding angles. Q, that's this one, has to be the same place as S, because those are the corresponding angles, etc. So, the answer is yes. The 2 sections will be the same size and shape. Alright, let's go on to page 3. Okay, third angles theorem. If 2 angles of one triangle are congruent to 2 angles of another triangle, then the third angles are also congruent. Okay, and this makes sense because you know all the angles have to add up to 180. So like, for example, if this angle is, I don't know, 60 degrees, and this angle is 50 degrees, then obviously if all the angles add up to 180, then this one has to be, let's see, that's 110, 70 degrees. And this one can't be anything else but 70 degrees also. That's just an example. So it makes sense that if 2 angles are congruent, the third angle also has to be congruent.
Then we are going to lower it down over these forms, turn on a vacuum under this table. It's called vacuum forming. And the plastic will cool down and take the shape of these forms.
So, for example, find angle V. So we're looking for this angle here. Angle SUT, that's this angle here, is congruent to angle VUW because they are vertical angles. Vertical angles, congruence theorem. You could just write vertical angles are congruent either way. The diagram shows that angle STU is congruent to angle VWS.
No, it'd be a little tough and chewy, I think. This stuff is
Okay.
when it says
Or VWU. I guess we'll use the middle letter since this angle uses the middle letter. You could call it VWS, but whatever. So, by the third angles theorem, angle S has to be congruent to angle V.
so is what we do to Buster.
By the triangle sum theorem, the measure of angle S equals 180 degrees minus 66 minus 44. And you know what I'm going to do? I'm just going to do these one at a time.
Well, this actually proves something for us right here. By the fact that we
That's 114 minus 44,
use, that's a possible reason
70.
batteries might exist.
So the measure of angle S, which we already determined equals the measure of angle V, has to be 70 degrees. Okay? Okay, example 5. Prove that triangles are congruent. Okay, we're given in the diagram FH is congruent to JH, FG is congruent to JG, and these angles are congruent, these angles are congruent. We need to prove that the triangles are congruent. Okay, this is the plan. We need to show, we're already given two sides and two angles. We need to show that this angle is congruent. I'm sorry, this side is congruent by reflexive property. That's HG congruent to HG. Obviously that's true. And the third angles theorem to show that this last angle is congruent to this angle. Okay, that's angle F congruent to angle J. So, we're given these sides. They're congruent. The third side, HG, is congruent to HG. We already determined that's reflexive property. These angles are congruent. That's given. And if those two angles are congruent, then angle F is congruent to angle J. That's the third angles theorem. So now we have all three sides. We have all three angles. If all three sides and all three angles are congruent, then the triangles are congruent. That's just the definition of congruent triangles. All right, last page. Theorem 4.4, properties of congruent triangles. Okay, pretty much the same thing as before. I'm going to draw these out. I apologize, they got cut off. That's C. That's F. And that's an L. Okay, so for any triangle, triangle ABC is congruent to itself. If ABC is congruent to DEF, then triangle DEF is congruent to triangle ABC. And the transitive property of triangle ABC is congruent to triangle DEF, and triangle DEF is congruent to triangle JKL, then triangle ABC is congruent to triangle JKL. Okay, and I'll leave these 3 checkpoint problems for you guys to do. They're cut off here, but they should be fine on your paper. And that's all for today.